Welcome back, everybody, to DellyMaths Concepts. What we're looking at today is the solutions for AdMath May 2024. If you're just coming to this channel, if you're new, I would like you to subscribe to the channel, like this video, and share it. So let us go. Question one. Question one says, determine the other linear factors of the polynomial 3x cubed plus 8x squared minus 20x minus 16, given that x minus 2 is a factor. If x minus 2 is a factor, what it means then, if I should do a long division, and I'm going to divide, we're going to divide 3x cubed plus 8x squared minus 20x minus 16. We're going to divide x minus 2 into it. So let us go. And whenever you're dividing, you're only using the x, right? So regular division, you divide, then you multiply, you subtract, you bring down. So x into 3x cubed will give us 3x to the second power. And then 3x to the second power times x minus 2. We're going to get 3x to the third. And then we're going to get minus 6x squared, right? And then we're going to subtract. So as you could see, we're subtracting 3x cubed minus 3x cubed. That's a 0. 8x squared minus. This is going to give us 14x squared. Then we're going to bring down our negative 20x. And then again, the x is going to go into the 14x squared. And that's going to give us positive 14x. Then you multiply 14x times x is 14x squared minus 28x. And what we're going to do here is subtract 14x squared minus itself. That's a 0. Negative 20x minus. Minus is a plus, right? So this is minus. So it is a plus positive. So it's going to be a positive 8. All right, very good. All right, so this is positive 8 right here. And so let's go now. All right. So x into 8x, we're going to get positive 8. 8 times x is going to give us 8x. 8 times negative 2 will give us negative 16. And if you put a minus here, 8x minus 8x is a 0. 16 minus 16 will give us a 0, as you could see. So here it is. That what we have is 3x squared plus 14x plus 8. Now we need to factorize this as quickly as we can. So basically, if you factorize this, you're going to have 3x here and x. So I guess we'll have a plus 2 and a plus 4. All right. So there it is. We're getting that. So these are linear factors. Now, what this really means at the end of the day is that 3x to the third plus 8x squared minus 20x minus 16 is equal to their first factor that they gave me, and then the 2 that I came up with right here. Our linear factors right here. So this is it. That's what we're looking for right there. All right, so that's what they were really referring to. That's 3 marks to do that. Let's jump to the other section. It says, hence, simplify the multiplication. Hence would have meant that those same responses, all right? So we're going to substitute this here, which is x minus 2, 3x plus 2, x plus 4. So I just substituted for that over this, which is the difference of 2 squared. So I'm going to represent it as x minus 2, x plus 2. So I'm factorizing the difference of 2 squared here. And then that will be multiplied by x plus 2 over x plus 4, right? So as you could see there, we have that. What we want to do here is just to pay close attention to the ideas. You can see that there's a lot of canceling that will be going on. For example, x plus 2 cancel x plus 2 here. X minus 2 cancel x minus 2. X plus 4 cancel x plus 4. What we're really left with is 3x plus 2 And that is our solution there when everything is simplified. All right. And that's a 2 marks here. Quite a nice flow going on. Let us take a look at question, the B part to the question now. So we're dealing with some beta and alpha, sum and product. All right. It says here the equation kx squared plus x is equal to 50. Kx squared plus x minus 15 equal 10 has roots A, alpha, and beta, where k is a whole number. Okay, k is a whole number. All right. And so let's take a look at what's going on right here. Number one says it determine the expression for alpha plus beta. Remember though that the sum of the roots, of which we call it alpha plus beta, is equal to minus b over a. We can find that by using the formula minus b over a. Let me write that a little better. Somehow that looks a little bit disgusting. So this is minus b over a. And the product, which is alpha times beta, is equal to c over a. So what we're going to do is to take that and represent it, because you notice this says write expressions for it. So then let us say we're taking a kx squared plus x minus 15 equal to 0. So from this, a is equal to k, b is 1, and c here, we have to work out c here, because all of this is equal to 10, should say 10 here. So to get this on this side, we're going to have to add, and going to have to subtract 10 from both sides, as you could see here. So we subtract 10 there, subtract 10 here. So technically what we have here is a kx squared plus x minus 25 equals 0. So c is equal to negative 25, right? With that said, we can simply take these. K, A is equal to K, B is equal to 1, C is equal to negative 25, and then represent it. So let us look at this. We want to write the expression for the sum, which is alpha plus beta. As we said, it is actually minus b over a. And in this context, minus b is going to be minus 1 over a, and a is actually k. The sum is minus 1 over k, but the product is going to equal to c, which is negative 25 over a, and a is called k. So these are the solutions that we're looking for. For the sum, we have a minus 1 over k, and for the product, we have 25, negative 25 over k, and we're good to go right there. All right. Now let's take a look at what else they want. So as we go further in the question, it says here, given that a alpha squared plus beta squared is equal to 61 over 4, use the expression above, which is these that we just have here, to determine the value of k. All right. Remember though, this, we need to remember the identity for this. So I'm just going to jump into it. So alpha, oh, guys, my screen is jumping. All right, let me put it there. So alpha square plus beta square can be represented as the sum, which is alpha plus beta, all square, right? Minus 2 times the product, which is alpha beta. So this is actually an identity that we can use to represent for this. So with that said, we can take this idea, and when I say this idea, I'm referring to take this, which is alpha plus beta square minus 2 times alpha beta, let that equal to 61 over 4, because it is 61 over 4. So let us do our quick substitution. What is the sum? The sum was minus 1 over k. So we're supposed to square that, because remember that was the, when we work out the sum, it was negative 1 over k. So we're going to square that, minus 2 times the product. And the product was actually, if I put it in a bracket, it was actually negative 25 over k. right? So negative 25 over k, take a look at them. Here is the sum, and that's the product right there. Now, let's keep moving. This is equal to 61 over 4. Let us work these out. Whenever you square anything, it is positive, so this becomes 1 over k. And this part, though, become positive 50 over k. This is equal to 61 over 4, right? This is k squared, my bad. So let us multiply throughout, right? Let us multiply throughout by 4k, 4k squared in terms of so that we could cancel. For example, we're going to multiply this by 4k squared plus 4k squared times the 50 over k. And that is going to equal to 4k squared times the 61 over 4. So basically what I'm doing is I'm multiplying throughout by 4k squared in an effort to do canceling where necessary. So let us see if we can do some canceling now. The k squared cancel right there. The k cancel, k squared leaving that this k, and then the 4 cancel 4 here. And let me rewrite what I have. So after we cancel, what we really have now is 4 times 1, and this is going to be 4. So we have a 4k times 50. That's going to give me 200k. And this is going to equal to 61k squared. Let us subtract 4 and 2 and subtract 200k from the left side, which means that on this side, we're going to have subtract 200k minus 4. Remember, though, that all of this is going to now equal to 0. So basically, this is what we really have. We have 61k squared minus 200k minus 4, and this is equal to 0. So this is going to be factorized. So we're going to have to solve this. So A is going to equal to 61. B is equal to negative 200, and C is definitely negative 4. In an effort to find K, we're saying that K is going to equal to the opposite of B, so it's going to be positive. So it's going to be positive 200 plus or minus the square root of B squared, which is 200 squared minus 4 times A is 61 times C is negative 4. All of this definitely must be over 2 times A is 61. Let us keep going. So this is going to be 200 plus or minus the square root of 200. This is going to give me 40,000, definitely. Let me work out the other one. That's negative 4 times 61 times negative 4. We're going to get about 976. All of this will be over 2 times 61. That's 122. Let's keep going. This is still 200 plus or minus. So this is the square root of 40,976 over 122. So let's find that 40,976, the square root of that. I'm getting some 202. All right, so basically this is what I have. I'm getting 202.4. Right? All of this would be over 122. At this time, we can just finalize the idea because k is equal to all of this. So here are the solutions. We're saying that k is equal to 200 plus 200 plus 202.4 over 2. That's one of the answer, which is going to give us 400 and over 122, my bad. So this is going to give us 400.402. Hold on, let me write this properly. All right, so we're talking about 402.4 over 122. All right, so let's work on 402.4 divided by 122. We're going to get a 3 point. So this is giving me 3.30. So that's one value for K. Also, we're saying that K is equal to 200 minus 202.4 all over 122. Let's do that. 200 minus 202.4. That's giving me, so definitely I'm getting negative 2.4 over. If we divide this by 122, we're done. I'm getting K is equal to negative 0.019. I'm just going to say 0.0196. That's what I'm getting right there. The question says here, it says, for the quadratic function g of x is equal to negative 5x squared minus 4x plus 2, determine the exact value. Determine the exact value of the, exact value of the maximum point and the range. Okay, when they say the exact value here, they don't want you to round it off, right? Because you may end up getting some fractions. So instead of round it off the decimal place, you're not going to round off your answer. You're going to keep it as a fraction. And that is why they really say exact here, because they did not want a rounded figure. So you want to keep it as fractions, because fraction is exact. But when you round off, not really. All right. There are many ways you can do this. So I'm going to do it one way. I know that you do it a lot of ways. I'm just going to do it one way. Let us go through this. What we have here is negative 5x squared minus 4x plus 2. I'm going to divide throughout by negative 5 because I want my square. I want the coefficient of the square to be a 1. So what I really have now is x squared, and this becomes positive 4 over 5x. This becomes negative 2/5 right here. So basically how we do this here is that I'm going to represent this x squared plus 4 over 5x. I'm going to leave a space to put a number here. So I'm going to complete the square here. And then this is negative 2/5. And I'm going to subtract whatever number I put there here. It's a half of b. This is 4 over 5. Half of it is 2 over 5. And I'm going to square it. But it's going to be a plus here. So I'm going to have to take it back here. So it's going to be a 2 over 5 square here. So basically, if I should just write this so that we could look at it, this is x squared plus 4 over 5x plus 4 over 25 right here. This actually becomes, if I should take this to the side, so this is like negative 2/5 minus 4 over 25. But if I want to work with the same denominator, I could multiply everything by 5 over 5. So I could multiply this by 5 and this by 5. So my denominator becomes 25. So this is like negative 10 over 25 minus 14 over 25. So as equal to minus 4 over 25. So we end up with minus 14 over 25 right here, which means that this is what comes here. At the end of the day, let us factorize this. This is a perfect square, so it's going to be x plus 2 over 5 all squared. And this is minus 14 over 25. To anchor the idea, remember that we divided in the early by negative 5. So we're going to have to multiply the two terms by negative 5. So when you do so, right, you could see negative 5 into this cancel, right? So this is going to be 5. This is negative 1. So what we're looking at here is when we do this, what I'm going to have here is this. So this is it now. Negative 5, open bracket, x plus 2/5. This is going to be squared. And then this is going to be positive 14 over 20 over 5. 14 over 5, all right? So it's going to be 14 over 5 because the negative and the negative, so this becomes 14. So let me highlight the response. So this is the answer right here. Well, this is what we're going to use to to get our answers. So now, in a response to the question, they want us to determine the exact value of the maximum point. So we're not going to round it off. So the maximum point is going to be, so max point here, as you could know, it's going to be that x value here, right here, which is going to be the opposite to it. So it's going to be negative 2/5, right? So negative 2/5 and 14/5, right? Because remember though that the maximum point, this is not this is not it. It's the opposite of this that will give us that. So it is actually negative 2/5 point, negative 2/5, 14/5. All right. What do they have? So for the range now, so g of x will be, so this has a maximum point. How you know? Because your a value was a -5, so the curve turned like this. So what we're talking about is that this coordinates that we have for a vertex here, the -2/5x, and then the 14 right here, right? All of that we have right there, we're saying is that this is our maximum value. So it's going to be less than or equal to that number right there. So the range is going to be that g of x will be less than or equal to 14/5. 2 minus log base 3 of y. I want to write this as a single log. All right. In represent it as a single log, you're going to put together some ideas that we know, right? So let us just kick this off as we go. First response is that, let me write back this. So we're talking about 2 log in base 3 of x plus 2 minus log base 3 y. Now, we could start off by representing this part. So there is an idea that said if you have n log x, right, in whatever base, it's going to equal to log in that same base of x raised to the n. So this is going to be log base 3 of x squared. Again, you could see that because it's a base 3, the log of 3 in base 3 is equal to 1. And we're going to have to represent that idea beside 2, because that's the only way we're going to end up getting our 2. So in other words, 2 times 1 here, but this is in base 3 log of 3, because this is actually 1, minus log base 3 of y. So that part is all right. Now, what we're going to do, remember, it's a single log we're going. This part of the deal right here can be now represented as a single log, because if you have the log, let us say in base x of a plus log, let us say, of x, all right, in b, it actually means that the log in base x of a, b, right? So we're going to utilize that. But at the same time here, now remember that this is actually going to come here. All right, it's going to come here. So we're going to get a 9 there. So let us rewrite this. I'm going to rewrite this for 1 minute. So this is log x squared base 3 plus log base 3 of 3 3's. This is going to give me 9. Because now this becomes like what we're just saying here, minus log base 3 of y. Now, applying the product now, this is going to be log in base 3, and this part, I'm actually going to have 9x squared minus log base 3 of y. Now, there's another rule that suggests that if you have the log, let us say base 2 of, say, a, minus log in base 2 of, say, b, as a single log, this is going to be log in base 2 of a divided by b, all right? So in that context, this here is going to equal to log in base 3 of 9x squared over y. So here it is that we have resort every single thing onto a single log, all right? There you go for 3 marks. That should be good. Let's jump on to the next question, which is the B part of what we're doing, right? So for the B part, now let us see what's going on. It says by using logarithm, all right, express the relationship V equal to 7 times 5t in linear form. So let me rewrite this just in case it's not really clear. All right. So we're dealing with my bad. All right, we're dealing with V equal to 7 times 5 raised to the t. All right, so we're going to have to just log everything. So if we're going to put it in linear form, remember the context of linear form is y is equal to mx plus c. All right, and we're going to have to look out for this part here where we're going to have the variable. Also, this is a variable. And I'm going to put this in blue where we have our constant. So we're going to look for the log of a number. For the c part, we have to keep those in mind. Hence, we might error. All right, so let us go. All right. So we're logging both sides. So this is going to be the log of v, which is going to equal to the log of 7 times 5t. Remember the same rule that when you multiply, it's going to be addition. So basically, I'm going to rewrite this as the log v, which is equal to log 7 plus log 5 raised to the t. Mark you that everything is in the same base, right? Again, we're going to employ that same rule where this power will become a coefficient in the next step. So we're looking at log v, which is equal to the log of 7 plus t log 5. So now we're looking out this. Oh, what did I do there? All right, let me write back my t here. This is my t. I was trying to highlight this. All right, so let's keep going now. If I should represent this in the linear form, I could write it like this. I'm gonna say the log of v, and I'm gonna set it to suit myself, where this becomes t log 5 plus log of a number 7. So this is like y equal to mx. I'm going to say xm, right? All right, plus c. The reason why I say xm is because the gradient is a number. So the log of 5 is a number. So I want you to see that. So these are variables here. This is a variable log of v with link to y, and x is t. All right. So basically, in linear form, this is the idea. All right. So that's the idea that we're looking. So how we're going to set it? So y is equal to mx plus c, right? Finally, you're looking at log v, which is equal to mx, as you could see. If you want to put it like, say, log 5 and then t here, right? Plus log 7 here. So this is like mx plus c, but as we could see, it was t log 5, right? So it's good to go as long as you understand what you're dealing with here, right? T log 5, I'm referring to this part, t log 5, but I wanted you to see y equal to mx plus c right here. So this is what they're referring to. And they give those a lot. Like every year I see something like this. All right, let's keep going. Hence, state the value of the gradient of the line. Hence, let me see what they're saying. Hence, state the value of the gradient of the line, which represent the relationship. Okay, so I want to state the value of the gradient of the line that represent the relationship. So remember that log v is equal to log 5. This is my gradient m t plus log 7, which is my c. That's my y. So if they said hence state the value of the gradient of the line, log of 5 is the answer. So my gradient here equal to the log of 5, which equal to 0.6987 with some multiple zeros and 4. All right, so basically log of 5 there would take us out right there. Let's jump to see the next one. All right, it says here that we want to rationalize this. It says rationalize the denominator of the expression 1 plus the root 2 divided by 3 minus the root 2. Whenever we're rationalizing, you're going to multiply by the conjugate. So what do I mean? So we have 1 plus the root of 2 over 3 minus the root of 2. The conjugate of this is to change the sign in the denominator. So it's going to be 3 plus the root of 2, 3 plus the root of 2. So we're going to multiply the numerator and the denominator by this. Let me write it in a little clearer spot, just a little bit below that, maybe here. 3, so it's going to be 3 plus root 2 over 3 plus root 2. And what's going to happen here, we're going to do multiplication. As you could see, this will multiply by this, and this will multiply by that right there. So let us take a look. Quickly, I'm just going to point some arrows. So I'm going to have 1 times 3, then 1 times that. So we're going to do regular multiplication, and then 2, root 2 times 3, root 2 times root 2. All right, so let us see, or well, we could do that. So 1 times 3 will give me 3, 1 times root 2. So we have 1 times 3, 3, 1 times root 2. So it's going to give me plus root of 2. So 1 times that. Then root 2 times 3, right? So it's going to be plus root 2 times 3, that is 3 root 2. Root 2 times root 2 will give me positive 2, right? All over. This is the difference of 2 squared. Look, 3 minus root 2, 3 plus root 2. So it's basically the difference of 2 squared right there. So basically it's going to be the square. So this is coming from 9 minus 2, right? In other words, the difference of 2 squared. So 9 minus 2 at the end of the day when we multiply this. Now let's take it a foot further. Let's put together our regular numbers. All right. So this is gonna give me 5. 3 plus 2, that's gonna give me 5. And then 1 root 2 plus 3 root 2 is gonna give me 5 plus 4 root 2, right? So I have 5 plus 4 root 2 right there. 5 plus 4 root of 2 over 7. Or you could say 4 root 2 plus 5 over 7. Same response, doesn't matter. The key thing when you rationalize is that you don't want any root in your denominator. And as you could see, the root is now gone. We have a 7 there. So for 4 marks, that's what you're required to do. Now, let us take a look at this right here. So as we go here, we're going to evaluate this. We're seeing here, we're moving from where 0 to 4. And so the idea is that we're looking at 5 raised to I minus 2 when I is moving from 0 to 4. So we could do these one at a time. So basically, we're going to sum the idea. So we're going to look at the idea when I is equal to 0. We're talking about 5 raised to 0 minus 2. So I'm substituting 0 for I. So technically, this is going to be 5 to the negative 2, right? 5 to the negative 2. And 5 to the negative 2 really means 1 over 25, right? So that is actually 1 over 25, or 1 over, this is actually 1 over 5 square, which is 1 over 25. The next one I'm going to, so that is 1/5. This one, so I actually jumped the gun. So this is 2 minus 2. So we have 5 raised to the 0. 5 raised to the 0 is positive 1, right? And then we're going where I is equal to 3. So we have 5 to 3 minus 1. So this is actually 5 minus 2. We should say 5 to the 1, which is as 5. We're going to add that. Lastly, I is now 4. So it's 5 raised to the 4 minus 2. You have to take time, you make mistake. All right. So this is going to be 5 squared, which is 25. If we're adding up this, 5 plus 25, that's, let me just highlight this. So 25 plus 5, that's 30. 25 plus 5, that's 30 plus 1. This is 31. And then we need to add these quickly. We can represent this as 5 over 25. So remember, working with the same denominator. So you multiply everything by 5 here. So we have 5 over 25, which is the same thing as 1/5. And so this is 1 over 25. When you add this, you get 6 over 25. So totally what we have is 31 and 6 over 25. That's my answer. I think this is 6 over 25 should result. Oh, so basically then, if I put it in decimal, I'm going to actually get 31.24. All right. All right, let us know, see what they want. Next question. Determine whether the following sequence is divergent or convergent. What do we know about when it is convergent? When you work out your ratio. Now, so when you work out your ratio, all right, the common ratio between these, if it is a value that is, and I'm seeing already where this, you could see, because you could see that it's a negative ratio. It's changing. Can you see positive, negative, positive, negative? So it's going to be a negative thing. But what we're saying here, if R, right? If my modulus of R is less than 1, if it's less than 1, it's what we classify as a convergent, right? So it is always convergent when the modulus is less than that. So what we're suggesting is you could take the terms, what I want to call them. All right, you could call this term 1, term 2, term 3, term 4. We could try any of these. We could try any of these. So we could say term 2, if you divide that by term 1, or if you divide term 3 by term 2, or term 4 by term 3. All right? So any two consecutive terms where the latter comes at the top, it's going to show you what it is. So for example, negative 2/3, if you should divide that by 1, I'm getting negative 2/3. Or if I had to use 4/9, if I should divide that by negative 2/3, I'm still gonna end up with negative 2/3, because what this is, if I could just work it out quickly for us, you could see 4/9. If you divide by that, you will multiply by negative 3/2. So you could see 2 here, and then 3 into 7, 1, 3 here, negative 2, negative right here. So you're seeing then that you're getting back the negative 2/3 again. All right. And then we proceed, we'll get the same thing. So basically, the common ratio between the terms, the common ratio is equal to negative 2/3. This is less than 1. So because this is less than 1, it is actually converging, right? Because it's less than 1. We did say if we work it out and we realize that it is less than 1, then it is converging, and we did get it. So conclusion, it is a convergent series or sequence. All right, so it is convergent sequence because we did start off and we got it as is. All right, we're in section 2 now. And section 2 says here, it says determine, let me see what's going on here. I'll push this a little to that side. So it says here, determine the points of intersection of the circle where x squared plus y squared minus 4x plus 6y plus 8 equal 0. And the line y is equal to x minus 6. What we're going to do, though, we're going to simply substitute. What we're going to do is to take, I'm going to take x minus 6 here as y. I'm going to substitute it. So let us write out what we got here. So we're looking at, you're looking at x squared plus y squared, but I'm going to write this as y. So it's going to be x minus 6. So x minus 6 squared. So that's y squared. So minus 4x plus 6y. Remember, y is x minus 6 plus 8. And this is equal to 0. All right, so we want to find, so we're just going to solve this. So let us keep working. So we have x squared. When we square this, we're going to get plus x squared minus 12x plus 36, right? So that is how you square a binomial. Square the first term, which is x, you get x squared. multiply the terms inside. X times -6 is -6x, a double, -12x, and -6 squared positive 36. Then we have minus 4x here, 6. So we have positive 6x minus 36 plus 8 equal 0. From here, you want to put together the terms that are alike, and I'm definitely seeing, I'm getting 2x squared to be alike, so I'm getting 2x squared here. Let me look again. We have -12x, that's -16x, and then positive 6, so this is -10x, I'm getting right there. And then if I put together the numbers now, positive and -36 is gone, so I'm left with positive 8, and this is equal to 0. All right, so everything is coming down now. You want to break this down because everything is divisible by 2. So you're looking at x squared minus 5x plus 4. This is equal to 0. And now you probably will be seeing it very easily where we have a x minus 1, x plus 4. X minus 1, x minus 4 right there, which suggests that if this is equal to 0, then x is equal to 1, x is equal to 4. Now, these are my solutions for x. Now, remember, I'm determining the points of intersection. So I'm going to need 2 coordinates. So I could say when x is equal to 1, remember, y is equal to x minus 6. In other words, y is equal to 1 minus 6, and this gives -5. One of my point of intersection would have been 1 with a -5. That's 1. When x is equal to 4, remember, y is still x minus 6. So this is going to be 4 minus 6, and this becomes -2. The second point is going to be my x, which is 4, and my y value, which is this. So x, y, x, y. And those are my 2 points of intersection. I'll highlight them. There they are. Those are the points of intersection as we go. All right. And I'm thinking I'm done here. I think I am done right there. So let's move on to the next question. Let's see what we have up our sleeve here. All right, so it says, so the B part of the question no says here, so it's a vector question. It says, given that the coordinates of the point A and B are 7, -3, and 2, 1, respectively. All right, so that means this is A and this is B. Those are points. That means we're on the coordinate plane. That means this is a position vector. It says state the position vector, we're told, all right, of the corresponding points in this format, right? So remember, in this format that we're going to put it in, basically the idea remains the same. So in other words then, you're thinking of like this ordinarily 7, -3. So all it's going to be is that you're going to have 7i. So this is O, let me write OA, hold on. OA is going to be 7i, and then it's a -3j, all right? Because it's the same numbers you're working, it's going to be I at the front and j. And then OB is going to be, where is it? Right there, 2, 1. So it's going to be 2i, and then 1j, we just call it j, right? So, so we have that. So we have a 7i minus 3j, and then this one is a 2i plus 1j, which is just j. It's a 1-mark question because an easy representation, and we're dealing with that. Let us see what the next question wants. So let us scroll. All right, so the next question wants us to work with AB. Remember now, condition, there are many ways you could do this. If you're moving from, if you want A, B, you want to displace these, you can set A to O, all right, plus O to B if you want. That's fine, all right? So A to O. So you could see that we have to change the signs for the, we had OA. So let me write OA was, what was it again? 7i minus 3j. So OA would have to change the component, the signs, because we change our direction. We're going AO. So this is now negative 7I and then plus 3J. And we're going to add that to OB, but OB remain in the same way. So it's going to be 2I plus J, right? So putting this together now, take a look at this. The I's doing algebra. So this is negative 5I, and then this is positive 4J. So that's the vector AB right there. And that's how you walk yourself through this. And I'm not saying this is the only way. You could have done this too. Remember that AB can be found by the position vector B minus the position vector A. So that means you would have put 2I plus J minus, and I'm going to put my parentheses here, 7J plus 3. So if you think about this, this is what we would get. Hold on. Hold on. So if you take now, so 2 minus 7, this is going to be a negative 5I. And then 1J minus 3, this is going to give positive 4J. So it's up to us. We'll get the same response. Doesn't matter. All right. The next question says calculate the value of the scalar product. Remember, with the scalar product, all we do is we multiply the i's, we add them, we multiply the j's, and we add them, basically. So let's put it together. Remember what the components were, right? We are looking at, what was it? Okay, we're looking at 7, negative 3, and 2, 2, 1. All right, good. So we're looking at 7, negative 3, and 2, 1. So basically then we're going to multiply this times this plus the result of this times that. So that is all we're doing. In other words, 7 times 2 plus negative 3 times 1. And then whatever we get here, this is 14 minus 3. The final response is 11. So the scalar product of OA and OB times OB is going to give us 11. And we're done. That's a 2-mark question. So basically, if you remember everything in terms of, you remember everything, you shouldn't have a problem with these. If you remember all that you need to remember. All right, let us grab this other question now. All right, let's grab this other question. All right, so the next question now says here, it says using PQ or R, write an expression for each of the following trig ratios. The sine of theta, remember, this is straight up so, ka, tower. Why? It's a right angle triangle. And so sine is going to be the opposite side over the hypotenuse side. Opposite side is here for sine. The hypotenuse side is Q. So it's going to be P over Q right there. For the cosine of that angle, cosine refers to the adjacent side, which is next door. So it's going to be A, and the hypotenuse side remains the same. It is Q. So adjacent over hypotenuse is going to equal to R over Q. All right, so there we go. So we have P over Q, R over Q. Let's keep going. So it says using the answers above, want to determine the value of sine square plus cot square. Recall that, okay, all right, good. So take a look at this idea. Remember though that sine theta was actually P over Q, and cos theta was R over Q. So let us square the idea. So sine square is going to equal to P over Q all square, which is going to give me P square Q square. And cos theta square will give me R over Q square, which is going to give me R square q squared, right? Now, let's add them. So let's add the idea. So sine square, which is p squared over q squared plus r cos square, which is r squared over q squared. When the denominators are the same, we learned this years ago, all right? You keep your denominator, which is q squared, and you add the numerator, so p squared r squared. Now, we're almost there. If you take your triangle that they gave you, this was P, this is R, and this is Q. Using the Pythagorean theorem, right? It is said that Q squared is equal to P squared plus R squared. So what it means, then I could substitute P squared plus R squared for a Q. In other words, I could substitute it right here. So I could substitute it for Q squared. That means I could put Q squared over Q squared. And this will work out to be 1. If I wanted to do it the other way, I could have substituted Q squared for P squared plus R squared. In other words, I would have P squared plus R squared over P squared plus R squared, because I would substitute this for that, and I'm still going to get 1. So the conclusion of what they had asked is that sine square theta plus cos square theta is equal to 1. And as you can see, we had proven that right there, right? Let's keep going. Now, we want to prove some identities here. What I normally do is just to relax, take the left side here, and I'm going to show that I could take the left side, manipulate it, and then show that I could get the right side, right? So let us start off with tan A. So tan A here. But normally, all right, I'm just going to say using the left-hand side, right? I'm going to rewrite as many things as I can. So tan is sine over cos. So instead of writing tan A, I'm going to write sine A over cosine of A. So that is representing that, plus 1 over, which is inverse if I want, but let me just relax. So it's going to be 1 over tan A again, which is the same thing as a sine A over cos A. As you can see, it's the inverse of it, right? So I'm going to rewrite this. So sine A over cos A plus, now I could flip this. I'm going to get cos A on top over sine A here, right? That is coming from this piece right here. All right, let's keep going. Now, if we work this to make it a single fraction, right? If we work this to make it a single fraction, then basically, as you could see, my denominator is going to be sine A cos A, as you could see. So when cos A go into this, I'm going to get sine A. So I'm going to multiply sine A times sine A. So I'm going to get sine A squared. Plus, when the sine A goes into this, it cancels leaving cos A. Cos A times cos A here is going to give me the square of cos A. Remember, though, that sine square A plus cos square A, we just say it is 1. So we want to recall that that is 1 from this question here. So let me just rewrite this. Sine square theta plus cos square theta is going to equal to 1. And we want to make sure to remember that. So as you could see, we substitute there, and we would have proven the idea right there. And there you go. All right, so it's all about taking one side, manipulate it, and then produce the other side without making any errors as you go. We're winding down. We're in the calculus, well, introduction to calculus anyway, section. So this part says here, using the definition of the derivative as a limit to find the derivative of x for the function f of x is equal to x squared minus 3. We know that this answer is actually 2x, but we're going to have to use first principle to determine that. What is the idea behind first principle? Then, all right, so basically what we have here is f, we want to find the derivative of f of x squared minus 3. I want to find the limit as h tends to 0, right? So what's going to happen here is this is the real formula that we always use, right? So this is what it says. The derivative of this is going to equal to f of x plus h, right? Minus f of x all over h, which is our small change. So basically, it's a small change in y over the small change in x, but this is how it works. And now, as you can see, our input was altered here. So we're going to substitute this wherever x is, all right, in the formula. For example, if you take a look, the input is what was altered by adding h. So then we're going to represent the idea. So here's the idea. X squared minus 3, and we're going to minus the f of f function, which is going to be, put this in the parentheses, all over h. Squaring our binomials, x times x becomes x to the second. H times x is going to give me hx, and we double that, we get 2. So this is positive 2xh. And h times h gives us h squared minus 3. When we distribute this negative inside, we get negative x squared, positive 3, and all of this is over h. When we do this, we're looking for things will be canceling now, as you know. Things will be canceling now. For example, you could see x squared cancel, negative x squared. We are looking for negative 3, positive 3. And so you're seeing those going. What we really have left at this moment is that we're looking at 2xh plus h squared, right, over h. What this really means is 2xh over h plus h squared over h. That's what we really have. So you see the h cancels there. So we have 2x here plus h. Here's the idea. Remember that h is tending to 0. So this becomes 0. So what we're really left with is that the derivative of f of x is equal to 2x. All right, because h was tending to 0. So that is what we refer to as our first principle as we go right there. Over y is equal to, given that y is equal to sine x over cos x, so show that the dy dx. Okay, so we want to differentiate this. All right, we could use our quotient rule. dv dx, when you differentiate cos, you're gonna get negative sine x, and when we differentiate u, we're gonna get cos x, right? So the formula is that what we normally do then is dy dx is going to equal to v du dx minus u dv dx all over v squared. Okay? All over v squared. It's going to be that. So in this case, what we're dealing with here is, as you could see, v cos. All right, I could just write it. So we have cos x, and then this is going to multiply by du this, which is cos x again, minus sine, where is it? Minus u, sine. And then that is going to multiply by negative sine squared, all over cos square x. All right, let's put it together finally. What we're looking at here is cos times cos. This is going to give me cos square x. Negative sine times negative sine, it's plus sine square x over cos square x. Remember, Cos square and sine square will give 1, and that is over cos square x. And we would have shown that, right? So basically, we have shown that dy dx is 1 over cos square x, and we're done. All right, let's go to the next question. So this question, you're going to employ the chain rule very quickly. So what it says here is the equation of a curve is given by y is equal to 5x squared minus 7. So, I mean, a quick way of doing this is like you could take the derivative of everything. Like this is what, well, you could write it in principle, but you could take the derivative of all of this, reduce that. So what's going to happen is 4 is going to come here. You're going to write back the entire ugly bracket and you reduce that. And then you're going to take the derivative of the inside and multiply by it. So the derivative of this is just going to give us 10x over here. You could just look at it like that. So you take the derivative of the whole thing, you understand? And then you take the derivative of the inside and you multiply it. You end up getting the chain rule there. So basically you're looking at 40x times 5x squared minus 7 raised to the third. Definitely, that's the answer for that. Very quick and fast if you want. All right, so for number 5, what we're actually doing here is that it says the region enclosed between the curve y equal to x squared plus 1. So the x-axis, the y-axis, and x equal is rotated around through x-axis through 360. All right, so what we want to do is to calculate the volume here. What we're gonna have to look at is the situation that we're dealing with will give us the area, basically. So y is going to be squared all the time. And we're looking at dx. So in this case, what we really have is that, remember that y is equal to x squared plus 1. And because we're going to do y squared, we're going to have to square this. So basically, the idea is that the volume here is going to equal to pi, the integral of this from 0 to 2, because we're moving from y-axis, which is where x is equal to 0 and x is equal to 2. So that's going to be the region. Y squared, in this case, is going to be x squared plus 1 all squared dx, right? So we're going to integrate that. So let us do that. So basically, the integration works the same way. We integrate this. What we're going to do is I would want to just clear this up and then work with the power rule. So in other words, how do I square x squared plus 1? It's going to be the same thing as x raised to the 4th. I'm squaring the first term. I multiply these and double. I'm going to get 1 times x squared is x squared. So it's going to actually become 2x squared. 1 times 1 is actually 1. So this is what I have. So I'm going to put this here. So I have x to the 4th plus 2x squared plus 1. So that is actually what I'm integrating and dx. All right, so if we go further, basically, let's start the integration process. The pi is going to be on the outside here. What I have here is that I'm going to add 1 to the power of 4, it becomes 5, and then we divide by 5. We're going to add 1 to the power of the square. So it's going to be 2x to the 3rd divided by the new power, which is 3. And then if you integrate 1, you're going to end up with x. All right, so basically, we're moving from 0 to 2. All right, so let us just find this value right here. Now, think about this. So this is pi here. I'm going to substitute 2, but because this is a 0 here, look, this is 0, and all of the variable, all right, here would become 0. So this part, I don't need to work out that 0 because I'm going to get 0, but definitely it's going to be pi. Let's substitute the 2 where x is. So I'll get 2 to the 5th over 5. I'll have 2 times 2 raised to the 3rd over 3 plus 2 right here. So if I put this together, I'll have pi here. This is actually 32 over 5. And this is 2 raised to the third is 8. 8 to 16. This is 16 over 3 plus 2. I could put this over 1. And if you give me a little time just to put this as one denominator, I could use 15. 5 into 15 is 3. And so we're talking about 3 times 32. That's about 96. So this becomes 96 here. 16, 3 into 15 is 5. 5 times 16 is going to give me 80. And 1 into 15 is 15 times 2, that's 30. So the pi is here. We multiply by everything here. Let us work out that. So that's 96 plus 8 plus 30. Hmm. 96 plus 80. Oh God, I put 8 here. 80. I did say 80. So 96 plus 80 plus 30. Yeah, I'm getting about 206 over 15. So the answer for this is actually 206 over 15 pi. All right, units to the third cube. So that's the response right there. All right, sorry about that. I put a 8 instead of an 80 just now, but I saw it right here. That was 80. All right, but we're good. So this is going to be the idea. I remember the reason why I didn't work out is because I'm going to get a 0 anyway when I plug in the 0 where all the x's are. And all my terms will be x. X is involved. So it's going to be a 0 for that part. All right. So basically, that is the answer for that. Let us take a look at this other part. It says, as a particle moves along a straight line, its displacement is measured from a fixed point O on the line. At time t, the acceleration A is given. So acceleration is given by this. Find the expression for the velocity v of the particle, given that when t equal 1, velocity is actually 3. All right. One of the things that we want to do here is that we have to make sure that we remember these ideas. If I'm going to find velocity is actually to integrate acceleration. So v for velocity is going to equal to the integral of acceleration, right? With time right there. So, so this is what we have. Now, let us take a look at what acceleration is. Acceleration is given as 24t minus 14. So basically, what we really want to do here is that we want to integrate 24t minus 14. We're going to do regular integral here. So let us get at it. So the velocity is going to equal to 24t to the second over 2 minus 14t. And if we simplify plus c, all right? So if we simplify this, what we're looking at is velocity is equal to 12t squared minus 14t plus c. Now, we need to find this constant here. In an effort to find the constant, we're going to go back to v is equal to 3 meters per second when t is equal to 1. We're going to substitute. All right, so right here, we could say 3 is equal to 12t. But remember, t is 1. So 1 squared minus 14t. T is 1 plus c. So come up here. 3 is equal to 1 squared is 1 times 12. That is 12 minus 14 plus c. So 3 is equal to negative 2 plus c. If I add 2 to both sides, I'm having 5 is equal to c. So now I have that my c is equal to 5. My velocity is going to equal to 12t squared minus 14t plus 5. And this is what they're looking for 3 marks right there. These topics are kind of nice. You know, we just have to make the links, all right, as we go. Now, let's take a look at the other question. So for the other question, where are you? So the other question, as you could see here, it says using your information above. In other words, then, let me write back this. The velocity was equal to 12t squared minus 14t plus 5. That's velocity. So using this, it says find an expression for s. All right, so s is the distance, displacement, all right, in a specified direction. The displacement is actually the integral of our velocity. In other words, then s is going to equal to the integral of our v dt, right? So if we integrate this, so in other words then, so let me come here, s is going to equal to the integral of v, but v is 12t squared minus 14t plus 5 dt. So if I integrate this, then we're good. So let us go now. S is going to equal to 12t to the third over 3 minus 14t squared over 2 plus 5t plus c. Let's break this down. So s is equal to 4t to the third minus 7t squared plus 5t plus c. All right. So having had those, what we want to do is to pick up ideas. Now we're told that t is equal to 1 when s is equal to 10. So what we can do is to substitute these right here. So s is equal to 10 because our intention is to find the constant c. 4 times t is 1, the third minus 7, 1 squared plus 5, 1 c. So 10 is equal to 4 minus 7 plus 5 plus c. All right, so 9 minus 7 is 2. So let's come here. So 10, negative 3, this is positive 2. So this is equal to 2 plus c. So you want to take away 2 from both sides. You're going to have 8 is equal to c. So if I know that my constant is 8, then I can rewrite this stating that the displacement is equal to 4t to the third minus 7t squared plus 5t. And then I'm going to be adding 8 to that right there. And that's going to be my displacement there. Let us see what else. All right. All right. So this is another question. So it says the gradient function of the curve C is given as a 7 minus 2x. All right. So we have 7 minus 2x. All right. So it is 7 minus 2x. It says if the curve passes through the point 3, 8, find the equation. All right. In a case like this, what we're going to have to do is to understand that gradient is the derivative here already. So we're going to have to integrate. And then after we integrate, we substitute this to find the constant, the point. So basically then what we're looking at is that if I want to find the original function y, it's going to be the integral of whatever we have now. All right, dy, dx, du. So what we're going to have to do is to jump at this. All right, here it is now that we're going to integrate. We are going to have to integrate this idea. 7 minus 2x dx. We're going to integrate this. So, so this is y. So y is going to equal to, this becomes 7x, and this becomes over 2. So basically, y is equal to 7x minus x squared, right? So I'm looking at 7x minus x squared if I never made any error. Add that to that, divide by that. All right, so I have 7x minus x squared. All right, so this is that, and then there's a plus c. Now, at this point, right, remember, no, at the point 3, 8, remember that this is x and this is y. So we're going to substitute so that we could know what the constant is. So basically, substituting here, we have 8 is equal to 7 times x, which is 3, minus 3 squared plus c. 8 is equal to 21 minus 9 plus c. So 21 minus 9, that's 11, that's 12. So we have 8 equal to 12 plus C. Subtract 12 from both sides. We could come here. So that's on the left side, I have negative 4 is equal to C. All right, so if C is equal to negative 4, then we could definitely now say Y is equal to, I could set this up the way in which I want. So I'm going to put the x squared part first. So it's going to be negative x squared plus 7x minus 4. So this is that equation of that curve with a gradient of 7 minus 2x, all right? And passing through that point at 3, 8. And we're done right there. All right, let's see what the next question is about. All right, I think we're winding down. Stem and leaf. So the questions are the height of 35 children at a nursery were recorded to the nearest centimeter. The data is shown. It says display the data, right? Shown above on a stem and leaf diagram. All right. So we're gonna have to quickly drop our stem and leaf diagram. For example, we're gonna have stem here, and I'm gonna put my leaf over this side. All right, so I'm gonna put the stems here and the leaf over this side. So basically, I'm gonna drop it here. This kind of in somewhat form of order. No, it's not in any order. So basically, I'm looking at from 60 onwards. So we're looking at 60s. All right, so we have 60s, we have 70s. Let me put this closer. We have 60s, we have 70s, 80s, looking at things in the 90s, in the hundreds, 110 going up there. All right, so we have those. So what we want to do is to quickly cross off the stuff as we go. The key is that we're suggesting that if you see like, so my key here is going to suggest that for my data, if you see 7/9, this is equal to 79. So I'm saying, right? So 61. So I'm going to put 61. So I'm going to put 1 crossing off this. I'm looking for things in my 60s. I see 62. So I have a 2. I have another 62. I see it somewhere here. All right. Then I have a 65. Boy, is a lot of crossing off. Quick, you know what I mean? So this is 65 right here. I think I see another 60, 67 right here. All right. Hopefully I didn't make any error. Trying to cross off as many. So we have we're in the 70s now. Take a look. So we have 70. That means 0 here. What else? 71. So there's 171. 74. I'm only seeing 174. 75. 175. I see a 76 beside it. How many 76? 176. So we keep crossing them. 78 here. How many? 1? Okay. All right, not too bad. 79 here. How many 79? 1, 2, 3, 79. Okay, 1, 2, 3, 79. All right, so we have the 80s now. How many 80 I see? Did I see 80? I see 180 there. All right, so there's 180. There is, so we want to do this as quickly as we can. 81, but you have to try not to make any error. No 82, there's a 83. There's a 84. All right. And there's also, where is it? 86. All right, so it's winding down. When I cross them off, you actually can go a little faster. So now I which is 90s, I see a 90 there. I didn't see any more. So 91, I don't see 91. I see 92. Okay, 2 92s. All right, so we have two 92s. All right, and is there any? Okay, no more. Oh yeah, no. Okay, I want to see 292. Oh, more 92. See, easily. You could slip up 94 is here. 94. I see 99. Okay. So we have 94, we have 99. I thought I saw 95. So yes, 95. So we have 95, we have 99. All right. Well, in the so everything, all right, we're almost done. So in the hundreds now, uh not seeing in 100, but I see 108, but 103 is here. 109 also. All right, so 103. I see 109. There's a 108 here. There's a 109 here. 109. Oh, another 109. All right, cool. So we have two 109s. Almost done. It's 108. And how many? Okay. There are two 108s. So this is 8 again, and this is 9. We just have to make sure that we're not making any error. I'm going to have to check off back. All right. Outside of that, 11. 111. So this is 11, 111. I'm seeing that. What else? 116. I see 116. I see 115 too. All right. So 16. So 15, 16 are there. This is kind of tedious right now, you know. Is there any more? Yes, 18. All right. Let me check to see how many, because we're told it's 35. I'm going to really check this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. No, this is 30. All right, so this is good. This is 135. Boy, a lot of work, tedious. So this is what you do for your STEM and leave just to get the marks. Honestly, it's a lot of work in terms of it's tedious, not difficult, but tedious. From this now, they want us to work out some stuff. So let us get into the whole math now. It says from the STEM and leaf that we have, we want to determine the values as follows. The median. Median is the middle, all right? So the middle. And when we speak of middle, we're talking about it's your Q2, right? Which is your second quartile, which is 50% of your data. But what we normally do here is that there is we normally find the position of the median simply by saying, guess what? N plus 1 over 2 will guide us to where it is. All right, so we're going to utilize that to help us. So 50% is actually a half of the data. So basically, this will take us to the number that we need. So remember now, 35 plus 1 over 2, that is actually 36. We're in search of, and then it's going to be half of that. So we are in search of the 18th term. So what we want to do is to count from this, the 18th term. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's my 18th term right here. So this is my median, and that's 84, right? So my 18th term landed on 84. So it's going to be 84 context is centimeters, right? All right. All right, so let's get to the next one now. Lower quartile. Remember what our lower quartile is. Our lower quartile is Q1, which is actually 25% of the sample. Context for the question, it's going to be 1 over 4 of 36. 1 over 4 of 36 is 36 divided by 4, which is going to give us the 9th term. So I'm just going to count 9th term. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So my 9th term, we put it in green, is going to be right here. And it is the 70s, it's going to be 75 right there. So 75, all right. So it's this, so this is 75 centimeters. So Q1 is actually 75 centimeters. I think that's the measurement that they have. Let me look back. Yeah, to the nearest centimeters. All right, good. All right, upper quartile is our third, which is Q3, 75%. And we know 75% is the same thing as 3/4 of this same 36. So 9. So this is 27th term. So let's go for term 27. So I'm not rushing it. We already know that the 4 is 18, 19, 20. 1, 2, 3, 4, 5, 6, 7. This is 103 for my upper quartile. So I'm getting 103 right there, to be exact. So this is 103 centimeters from my third quartile. And so easily we walk ourselves through this. Let us see what the other question is. So the question went further, and it says here, the question went further, and the question says, another nearby nursery, right? At another nearby nursery, the height of the children of the same age were recorded. The median was, so this median is 79, and the interquartile range is 24. Compare the characteristic of the two groups at the nurseries and describe one distinct observation. All right, so what I'm gonna have to do here is I'm gonna look at, so I'm gonna call this maybe nursery 2. All right, so I'm looking at nursery 1, which is the original one that we did. So for nursery 1, we wanna look at our interquartile range, right? So interquartile range is gonna be Q3 minus Q1. So we wanna compare because we have theirs is 79. So our Q3 was 103. Our Q1 was 75, I believe. I think I'm remembering right. All right, good. So let us subtract the two to find what ours was. So 103 minus 75. We're getting 28 here. 28. This is our interquartile range, is 28. Their interquartile range was 24. All right, so ours is 28. All right, good. Now, so we have everything in context. So compare the characteristic of the two groups. So I could say group 1, which is nursery 1. I'm comparing 28 to 24, which means that I have a wider spread from my mean. In other words, then, if this is my distribution here and this is my median, which was, I think the median was 84, there's a spread, a wider spread subtracting 28. I'm just going to put the numbers here just to look at them. We could come up with a quick discussion. This goes as far as 56. And if I add it to the 84, I'm working with, so 84 plus the 28, it's going to go up to 112. All right. So this is all the data. We're saying that it's spread, right? So we're getting a spread like that. All right. So what we want to do here is says, at nursery. So I'm going to put my nursery 1, which is the original one. All right. I'm going to say there is a wider spread. There is a wider spread at the middle 50% of the data set compared to nursery 2. All right. So the reason why I said there's a wider spread is because our interquartile range 28 is bigger than theirs, which is 24. So we are at the middle 50% because Q1, so here it is. We have median, Q1, Q2, Q3, all right? And what happened here is this is at the 25% mark, this is at the 75% mark. The difference between this, if I should say 75 minus 25, you're going to realize that this between here, this is a 50% and it's in the middle because there's 25% down here and there's another 25% up here. What we're suggesting is that for nursery 1, which is the one that we worked out, there is a wider spread in our middle 50 compared to nursery 2. There's a is not as widely spread as ours because it's 24 compared to 28. That is all, right? And so basically we could look at that. That's it. The fact that we're looking at the spread at the middle 50% right there. All right, so let's see now. It says a bag contains 6 red marbles and 5 black. That's 11. All right, so we have 6 red and we have 5 black. All right, so that's what we're dealing with now. We have 11 marbles in total. So we're saying that during 2 rounds of marble games, a student is required to randomly draw 1 marble without replacement. So the numbers will be reducing as we go for each round. We want to construct a probability tree diagram to represent the information. All right, good. So we drawing that. So basically, this is what is going to happen. So this student will be drawing from the back. We have 2. We have red, we have black. So let's just say we have red here, and we have our blacks here. Right? All right, so we have red and we have black. Remember, though, that we're dealing with 11. All right? So the red is 6 out of 11. The black is 5 out of 11. Right? So that's what we start off with. This is actually the first round, right? So for first round, you can only draw 6 out of 11 for red and then 5 out of 11 for black. When you reach here, then you're going to split again into red, black, because you have the opportunity to draw. So again, this is going to be red again, and then here is going to be black again, all right? Here is going to be red, and here is going to be black. And we're talking about following the branches. You see what goes on. But remember now, for the red, now it is going to be 5, all right, out of 10, because 1 is gone. All right. But for this one, if you had drawn a red, that means the black would have been untouched. So the black would have been now 5 still out of 10 because we didn't touch the black in that case. If we now come here where we're looking at the black here, 5 out of 11. When we draw again, to draw black again now, it's going to be 4 out of 10. But for the red here, since we wouldn't have touched that red right here, right? Oh, I put that in the wrong spot. My bad. My bad. Let me speak to the red here. We still have 6 out of 10 here. But for the black, this is what I was saying, would have been now 4 out of the 10 because you would have drawn 1 black already and then draw black again. All right, so basically these are the numbers that we're working with here for the tree diagram. So this would give you full marks here. So so let us see the questions that they would want to ask us now, right? Let's see the questions. The question says, using your answer right there, find the probability that the marble drawn are all the same color. All right. So what it means, if you're going to draw the marbles that are the same color, all right. So we're talking about the probability that we're going to draw a red and a red, right? That's one case. We also intend to draw the black and then draw black again. Now, the thing is, In order to do this, we're talking about the same color. All right, we're talking about the same color. It's going to equal to join my red, red, right? Or I could be drawing my black, black. So you're going to combine those, but it's going to be an R, which means that we're going to be adding the idea. So if I'm going to draw a red at first, based on what we have, we would have had, let's put it together. If we say red at first, you're talking about 6 out of 11 times 5 out of 10, right? That's red, red. Also, for the black, we would have had at first 5 out of 11. And then the next go is 4 out of 10. We can break down things if we want. For example, 5 into itself 1, 5 into this 2, 2 into itself 1, 2 into this 3. So basically what I'm looking at is 3, 2 into that 3, 2 into that 3. All right, so I'm looking at 311, right here. This is 3 over 11. Let me break this down. 5 into that 1, 2 into that 3. Yeah, so this is 3 over 11 for that part. For this part, 2 into this 2, 2 into this 5, 5 into this 1, 5 into that 1. So this is 2 11th, right? So if we put this together, 311 plus 211, I'm finding at the end 5 out of 11. And that would have been the answer if we're supposed to draw red, red, or a black, black, right? Probability, 4 marks for that. Easy cheese. All right, we're going. Let's see what else is coming. All right, we're almost there, almost there. All right. It says, given two events, A and B, we have P, the probability of A union B is equal to 0.7. Probability of A is 0.3. The probability of the complement of B is 0.6. This is not B. So one needs to take the time out to make sure that you find the probability of B. The probability of B is to understand that probability sums up to 1. So definitely it's 1 minus the complement here, and this would have given us 0.4. We have to look out for these tricks with that little thing there. And then now what we want to do is to find the intersection. The intersection is given as follows. The probability of A intersect B can be found by the probability of A plus the probability of B minus the probability of their union, which is A union B. Definitely the probability of A was 0.3. Probability of B 0.4. Probability of the union, we got that, minus 0.7. So this is definitely 0.7 minus 0.7, and the answer for this is 0. So there is no intersection here. This is a null set that we have here for that. So there is no intersection for 3 marks. So it says, what is the relationship between event A and event B? Truth to be told, if there is no intersection, what we have is actually, we have a disjointed set. So our sets are disjointed. So this is A and this is B. They share nothing in common, right? So in terms of the relationship between these sets, we could suggest that events of set A is mutually exclusive of the events of set B. In other words, then, their intersection is so their intersection A intersect B will give you an empty set. There is nothing there. So the sets is like this. I'll say that to get just a 1 mark, right? Let us see what else coming. Are we done? Okay, exam is done. All right. Thank you for watching. Share the video, like. See you next time. Bye-bye.